Welcome to everyone. I am Dr. P.Saranya, Assistant Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Autonomous, Salem. In this video, we are going to see the topic about partial differential equation. First, we see the introduction of partial differential equation. Partial differential equations are used to mathematical formulae and thus aid the solutions of physical and other problems involving functions of several variables such as the propagation of heat or sound, fluid flow, elasticity, electrostatistics, electrodynamics, etc. For example, fluid mechanics is used to understand how the circulatory system works, how to get rockets and planes to fly, and even to some extent how the weather behaves. Similarly, some examples are given below. Next, we see the definition of partial differential equation. An equation which involves a dependent variable and its derivatives with respect to two or more independent variables is called partial differential equations. Here, we give one example for partial differential equation. X dou z by dou y plus 4y dou z by dou x equal to 2z plus 3xy. Next, we see the notation of partial differential equation. P equal to dou z by dou x, Q equal to dou z by dou y, R equal to dou square z by dou x square, S equal to dou square z by dou x dou y, T equal to dou square z by dou y square. Next, we see the definition for linear and nonlinear PDF. If the partial derivatives of the dependent variable occur in first degree only and separately, such a partial differential equation is said to be the linear, and the other things are all non-linear partial differential equation. In that, partial differential equations are formed in two types. First method by the elimination of arbitrary constants, and then second one is by the elimination of arbitrary functions. Now we see an example problem for by the elimination of arbitrary constants. First problem is form the partial differential equation by eliminating the arbitrary constants a and b from z equal to ax plus by plus ab. First we have to consider the given one is an equation number 1, that is z equal to ax plus by plus ab, and differentiating this equation partially with respect to x. Then we get dou z by dou x equal to here a. Already we use one notation dou z by dou x equal to p. So dou z by dou x, which is equal to p, equal to a. And similarly we have to differentiating partially with respect to y. In equation number 1 we get dou z by dou y equal to b. Already we see notation dou z by dou y equal to q. So from this q equal to b. We substitute the value p equal to a and q equal to b in equation number 1. Finally, we get z equal to px plus qy plus pq. This is the required partial differential equation. Next, we see the another problem for eliminating the arbitrary constant. Here they giving z equal to ax plus by plus a square plus b square. First, we have to consider z equal to ax plus by plus a square plus b square. Differentiating this equation partially with respect to x, we get dou z by dou x equal to a. Substitute dou z by dou x equal to p, which is equal to a. And similarly, we have to differentiating equation 1 partially with respect to y, we get dou z by dou y equal to b, that is q equal to b. Now we have to substitute p equal to a and q equal to b in equation number 1. We get z equal to px plus qy plus p square plus q square. This is the required partial differential equation. And next we see the b subdivision. The given thing is z equal to ax plus by plus a by b minus b. Differentiating this equation partially with respect to x and y, we get dou z by dou x equal to a, that is p equal to a, and dou z by dou y equal to b, that is q equal to b. Substitute the value for A and B in equation number 1. Finally, we get Z equal to Px plus Qy plus P by Q minus Q. This is the required partial differential equation. Next problem is form the partial differential equation by eliminating the arbitrary constants from x minus a the whole square plus y minus b the whole square plus z square equal to r square. This is the equation of sphere of radius or having their centers on xy plane. That is x minus a the whole square plus y minus b the whole square plus z square equal to r square. You have to consider this is equation number 1. Differentiating this equation 1 partially with respect to x, we get 2x minus a plus 2z dou z by dou x equal to 0. From this we get x minus a which is equal to minus zp. You have to substitute the value dou z by dou x equal to p. So we get x minus a equal to minus zp. Similarly, we have to differentiating equation 1 partially with respect to y. We get 2 into y minus b plus 2z dou z by dou y which is equal to 0. Similarly, you have to substitute dou z by dou y equal to q. So, y minus b equal to minus zq. You have to substitute x minus a value and y minus b value in equation number 1. We get minus zp the whole square plus minus zq the whole square plus z square equal to r square, which is the required partial differential equation. Next we see the another problem for partial differential equation by eliminating the arbitrary constants from log az minus 1 equal to x plus ay plus b. Differentiating this equation 1 partially with respect to x and y, we get 1 by az minus 1 into a dou z by dou x equal to 1. Here you have to substitute the notation for dou z by dou x equal to p. So we get 1 by az minus 1 a into p which is equal to 1. Simplify this one, ap equal to az minus 1. Similarly, you have to differentiate equation number 1 partially with respect to y. We get 1 by az minus 1 into a dou z by dou y equal to a. This implies AQ is equal to AZ minus 1 into A. You have to divide equation number 3 by 2, which gives Q by P equal to A. From this AP equal to Q. Substitute equation number 4 in equation number 2. We get Q equal to Q by P into Z minus 1 or PQ equal to QZ minus 1. From this, P into Q plus 1 equal to Q square, which is the required partial differential equation. Next, we see the another problem for partial differential equation by eliminating arbitrary constant. The given question is 2z equal to x plus a the whole power 1 by 2 plus y minus a the whole power 1 by 2 plus b. You have to take 2z equal to x plus a the whole power 1 by 2 plus y minus a the whole power 1 by 2 plus b is equation number 1. Differentiating 1 partially with respect to x, we get 2 into dou z by dou x, that is equal to 2p equal to x plus a the whole power 1 by 2. You have differentiating with respect to x, what we will get 1 by 2 root of x plus a, and then remaining things are 0. You have to simplify this one. Finally, we get root of x plus a equal to 1 by 4p. So, x plus a equal to 1 by 16p square. Similarly, we have to differentiating equation 1 partially with respect to y. We get 2 dou z by dou y equal to 1 by 2 root of y minus e. You have to substitute the notation dou z by dou y equal to q. So you get 2q equal to 1 by 2 root of y minus e. That is root of y minus a value which is equal to 1 by 4q. So Here you have to add equation number 2 and 3, x plus a plus y minus a, which is equal to 1 by 16 p square plus 1 by 16 q square. Here a get cancelled, remaining thing is x plus y, which is equal to 1 by 16 1 by p square plus 1 by q square. So 16 into x plus y, which is equal to 1 by p square plus 1 by q square. And then you have to cross multiply the right hand side. 16 into x plus y, which is equal to q square plus p square by p square q square. So 16 into x plus y into p square q square, which is equal to p square plus q square, which is the required partial differential equation. Next we see a problem for eliminating arbitrary constant, that is z equal to ax cube plus byq. So you have to consider, that is equation number 1, differentiating equation 1 partially with respect to x and y, we get dou z by dou x equal to 3ax square, and you have to substitute the notation dou z by dou x equal to p equal to 3ax square. From this we get a value, that is a equal to p by 3x square. Similarly, you have to differentiate equation number 1 partially with respect to y. We get dou z by dou y equal to 3by square, or q equal to, substitute the notation dou z by dou y equal to q equal to 3by square. From this, b value equal to q by 3y square. Substitute a and b value in equation number 1. We get z equal to p into 3x square into x cube. Here x value get cancelled, the remaining thing is p by 3x. Similarly, you have to substitute b value in that b place, q by 3y square into y cube. So finally we get the answer is 3z equal to px plus qy. Next we see the another problem for the partial differential equation by eliminating the arbitrary constants. It is x minus a the whole square plus y minus b the whole square equal to z square cot square alpha. You have to consider, this is equation number 1. Differentiating equation number 1 partially with respect to x. Here we will get 2 into x minus a equal to 2zp 2z dou z by dou x into cot square alpha. You have to substitute the dou z by dou x value is equal to p. Finally, we get x minus a equal to zp into cot square alpha. Similarly, differentiating equation number 1 with respect to y. 2 into y minus b, which is equal to 2z dou z by dou y cot square alpha. You have to substitute the dou z by dou y equal to q. You have to consider, this is equation number 2 and this is equation number 3. Substituting 2 and 3 in equation number 1, we get zp cot square alpha plus zq cot square alpha is equal to z square cot square alpha. From this, the required partial differential equation is p square plus q square equal to tan square alpha. An example problem. Next we see an example problem for partial differential equation by eliminating the arbitrary function. Z equal to f of x square plus y square. Here put u is equal to x square plus y square. In equation number 1, we get z equal to f of u. Differentiating equation number 2 partially with respect to x, we get dou z by dou x equal to f dash of u into dou u by dou x. That is, f dash of u into dou u by dou x value is 2x. Already we know notation is dou z by dou x equal to p. So p equal to f dash of u into 2x. Similarly, we have to differentiating equation number 2 partially with respect to y. We get dou z by dou y equal to f dash of u dou u by dou y, which is equal to f dash of u You have to differentiating this u value with respect to y. We get 2. Substitute here. And then dou z by dou y equal to q. So q equal to f dash of u into 2y. Then this is equation number 4. Now we have to divide 3 by 4, which gives p by q equal to f dash of u into 2x divided by f dash of u into 2y. Here f dash of u into 2 value get cancelled. Remaining thing is p by q equal to x by y, and then cross multiply, we get py minus qx equal to 0, which is the required partial differential equation. Next we see one example problem for partial differential equation by eliminating the arbitrary function, that is pi of x square plus y square comma z minus xy equal to 0. This equation can be written as z minus xy equal to f of x square plus y square. In this equation we have to eliminate that function f. So we have to differentiating equation number 1 with respect to x. We get dou z by dou x minus y equal to f dash of x square plus y square into 2x. Here you have to substitute dou z by dou x equal to p. So p minus y equal to f dash of x square plus y square into 2x. Similarly, you have to differentiating equation number 1 with respect to y. That is dou z by dou y minus x equal to f dash of x square plus y square into 2y. Dou z by dou y value which is equal to q. So q minus x equal to f dash of x square plus y square into 2y. Divide equation number 2 by 3. We get p minus y by q minus x equal to f dash of x square plus y square into 2x divided by f dash of x square plus y square into 2y. Here f dash of x square plus y square into 2 get cancelled. Remaining thing is p minus y by q minus x equal to x by y. And we have to solve this one. Finally we get py minus qx equal to y square minus x square, which is the required partial differential equation. Next we see another problem for partial differential equation by eliminating the arbitrary function from z equal to f of x square minus y square. Here you have to consider the equation number 1 is z equal to f of x square minus y square. Here you have to take u equal to x square minus y square. Substitute that u value in equation number 1, z equal to f of u. Differentiating equation number 2 partially with respect to x. We get dou z by dou x equal to f dash of u dou u by dou x. This is equal to f dash of u dou u by dou x value is 2x. And then dou z by dou x is equal to p. So p equal to f dash of u 2x. Similarly, we have to differentiating partially with respect to y. We get dou z by dou y, which is equal to q f dash of u into dou u by dou y, that is minus 2y. So you have to divide equation number 3 by 4, which gives p by q equal to f dash of u 2x by minus f dash of u 2y. Here f dash of u value get cancelled. Remaining thing is p by q equal to x by minus y. And simplify this one, we get px plus qy equal to 0.